Good afternoon and good morning to everybody. It is a pleasure to have you all with us today for Airborne Robotics and Essex Systems Aerial LiDAR Applications webinar in partnership with LiDAR Creator. My name is Keegan Schiff and I'll be hosting today's webinar. Without further ado, I'm going to dive straight into it. I present our speakers for the day. Our first speaker today will be Alex Freyes-Erfalt. He is the Chief Executive Officer of Essex Systems and Airborne Robotics. The second speaker for the day, Eric Froman. He is the Chief Technical Officer of Geotech and LiDAR Creator. So they're going to be doing the presentations for the day, and this will be a 45 minutes. Well, we'd like for it to stay within the framework of 45 minutes. So without further ado, we'll be running through the technical equipment, which will be done by Alex. Once Alex has presented his presentation, we'll then show you a short data capture video from our previous LiDAR demonstration. After that, Eric will then take over and give you a few samples of building surveys, including workflows and data outputs. Then he'll close off with LiDAR use cases. So at the end, we'll have a few Q&As. And just so everybody is aware, the Q&A is found, if you have any questions that you would like to ask, if you take a look at the attendees, the participants section, you will see an option for Q&A. If you click on that, you'll then be allowed to ask any question you would like, and we'll do our best within the time frame that we have to answer as many of those questions as possible. Without further ado, Alex.
Thank you, Keegan, and also welcome from my side. Good afternoon. I'm here in London, kind of playing the lockdown card. Good afternoon from my side as well. To start off, I would like to give a short overview about on Essex Systems Airborne Robotics. We are a manufacturer of drones. We are based in Austria, Germany, and the UK. And in the UK, we have got offices in London and Basingstoke. Basingstoke happens also to be the building which we are surveying, which we have been surveying for our live event and will also demonstrate today. So we have a track record going back to 2014 for manufacturing drones and are known for turnkey systems and customizations, but also for product endurance, stability, and safety. And when it comes to safety, just moving clockwise here on that slide, you can see the drones up to 60 minutes flight time, up to 10 kilos payload, but also what is quite important, our redundancy feature, which is quite unique in the market. So all the electronic components in the drone are twofold. So if one fails, there's a second one. And then secondly, the wind and water resistance, which is quite important in particular when you are out in the field in the UK or close to the shore, etc. What matters, moving on here clockwise as well, what matters for surveying is of course accuracy and precision, which comes from the drone, but also from the sensors. Then the system and sensor integration for smooth workflows is very important. We have mentioned redundancy and also the wind and weather reserves. Moving on clockwise again, we're displaying our top sectors consisting of the power sector. And when I talk about power, then I mean electric power, power distribution, power lines. Then the wind sector, wind energy, so offshore, onshore wind energy. Then oil and gas and other infrastructure. Secondly, the large sector of surveying, which includes also mining and construction, which historically has been our most important sector. In 2021, now it has moved to number 2. Then lastly, agriculture and forestry, also a very large sector, which includes also logistics, for example, logistics in forestry. All three sectors together account for about 90% of our sales. And LiDAR is very important for all of three of them. And that's why LiDAR applications are so important for Airborne Systems and Airborne Robotics as such. So to cover the question what we do, so we have this this range of serial products apart from customizations, so serial products here, and this is the broad selection of our current 5 products. Starting off, the smallest one is a nano drone below 250 grams. Then our indoor drone, which is below 2 kilos. Then the drones which are used for mostly photogrammetry, but also inspection. So the EF4 drone, it's a very powerful drone which can theoretically also mount smaller LiDAR systems. And then our typical photogrammetry drone is the EF6. And then today's, let's say, flagship drone, which is also used for our tests, our LiDAR surveys, is the Air 8 medium lifter, which can lift up to 10 kilos, theoretically even more, up to 15 kilos. Why do we have this high performance orientation? Because we want to make the impossible possible. And when we say that, we, for example, mean what we have achieved in Croatia some 18 months ago. It's a survey of 8 kilometers of corridor of the longest cable car to be built in Europe. It's a mountainous region at the coast. So we are going up basically from 0 to 1,500 meters in height. And dense vegetation. And if you see this image here on the right, you can see what was awaiting us when we entered here. That's around the second starting point. So we have this little road, and then we have a wall of trees on the left and on the right. So we had to use a lifting truck in order to be able to follow the flight path of the drone in order to fly a line of sight. So this would not have been possible with any other drone than the Air 8. And you can see here the corridor from a different angle. So here's the coast, and here's this 1,500 meters peak of the mountain. So a powerful drone system is required with reliable waypoint planning. And in order to fly as close as possible and as low as possible to the surface. So there's a terrain follow function required that works very well. And also the comms have to be equipped so that we can do ranges which are required for this here. Moving on from here, let me just find the slide. So this gives you a little bit an overview of the different LiDAR systems we are using. So our key solutions are really the 2 on the top. One is a larger system with about 6.5 kilos from Riegel with 3 cameras here. And the one we are presenting today is the one of the red drone. It's the LiDAR LiDAR system, which is a lightweight and very efficient way of doing LiDAR surveys. Eric will talk about this and also about the weight, but we are below 2 kilos in weight here, so that's very, very good and very efficient for a system. We have talked about the EF4. So EF4 is a compact drone which can also be used for LiDAR, but also other functions, so I won't go too much into that. I wanted to mention also a smaller drone. It's a good extension of the range. So it's a very small drone below 250 grams. And it was really designed for tactical surveillance to be the eye in the sky. Apart from the serial product, we work on different projects in partnerships with other companies because we believe in full autonomy. And one of these examples of full autonomy across various subsystems is the Dr. Suit project, how we call it. It's basically a fully autonomous system of consisting of an autonomous vessel with a swarm of drones. So just to give you an idea of the things we are doing besides our main product range. Similar also in the agricultural area. This is a root detect, a project we are doing with partners in the UK and in Canada. Now moving to the LiDAR and LiDAR Reto partnership here. This is an example of what we have recently done with our Air 8 and the LiDAR Reto system. It's a survey of a rail track. We have been getting a lot of requests for rail surveying and rail surveying solutions over the last, I would say, 18 months, 24 months. And what is really required here is centimeter accurate accuracy and point density, because if you look at the rail, if you look at the rail infrastructure, you have lots of smaller components, and if you want to have the full picture for a digital twin, for example, of the rail network, you really have to have the granularity and the accuracy and also the point density to display that, and that means you need a good system. Digital twins, I think, is a thing which we read a lot about, and we can hopefully also in the future contribute a lot to it. And this will be, this is basically power lines, rail, as we said, wind energy, forestry, oil and gas. Of course, a lot with historic buildings and urban development. And so, for example, we have been working on a whole urban, let's say, area in Tallinn in Estonia, where we used our Air 8 with the LiDAR system. LiDAR gives you a broad functionality, so that's why it is so interesting. It not only gives you the 3D model and the point cloud, but also, of course, an elevation model and the terrain shape. Yeah? So you can basically typically have the first and the strongest return. So the first return would be the canopy. For if you, for example, take forest, that's the cover, the top of the trees. But you can also strip that out and go down to the surface and then have a surface model. So that's the interesting component of LiDAR, but we will hear much more about that from Eric in his presentation. But you can also monitor growth of vegetation, growth of plants, but also growth in terms of construction progress, for example. Or if you monitor a big open pit mine, that's the same. You can monitor how the surface moves and develops. For rail-specific applications with LiDAR, and if we have participants from the rail sector on this event, they might be interested in surveying, in exact surveying of the elements along the rail network. And that's really possible also with LiDAR, but it needs to be a LiDAR which has the, let's say, characteristics to do that. So that's, sorry, that was the wrong one. With regards to our test or demo LiDAR survey we've done. So this is Worting House and the property from the air. So we have done a very simple mission planning of it in order to conduct the LiDAR flight. If you see here the home point, and then the drone moves from the home point to flight line number 1. And there's for this planning there were 7 flight lines. We have chosen to fly it this way. We could have used less flight lines, for example, 4 or 5, maybe 4 would have been enough. And then we could have also taken 2 across. So there's different ways to do that. But typically, LiDAR is a very efficient way of collecting data. If you fly, for example, at 50-meter height, you can get a corridor of up to 100 meters. So this is quite a sufficient way of covering areas. Yeah, so this was flown at 30 meters. So as I said, relatively low. That's the reason why we've also used quite, let's say, more flight lines than we would have typically planned. And we have flown at 5 meters per second in order to cover the area. So next on the plan would be a short video of the data collection. Keegan, can I pass on to you?
No problem at all. I will take control. Thank you so much, Alex, for your insightful presentation. I'm sure everybody found that very interesting. Thank you so much. Eric, if you would like, you can take over from here.
Okay, thank you, Keegan. Okay, so hello, everybody. Thank you to Keegan, thank you to Alex, to whole Air6 Robotics company to allow me, to allow our company to attend and join this presentation. And I would like to introduce our solution, our product called LiDAR APPLICATIONS. Few words about our company, who we are. Our company is Geotech Bratislava. So we settled in Bratislava, Slovakia. Our company was founded now 27 years ago, and we are purely reselling oriented especially for surveying market, GIS market, laser scanning, UAV, so on. Most of us are educated surveyors, and the surveyors are our biggest group of the customers. We represent several leaders in the industry, like Leica Geosystems, Hexagon, Novatel, Handheld, and other companies. We are ISO certified company, and in 2015 we have found a demand for LiDAR systems, especially for cost-effective compact LiDAR, which our traditional supplier could not offer. So that time we decided to build our own system. So now it's about 6th year we develop our LiDAR. Since beginning, our idea was to bring a compact, small, easy-to-use device, which is not designed only for one platform, but for several platforms, meaning UAV, or drones, car, or backpack. So this was from the beginning our main idea, and we see it as a big benefit of our solution that our customers really appreciate, and because they can invest in one single device only, single unit, and very simply swap it between different moving platforms. It's a kind of mobile mapping. So this is our focus, and what we integrate on the LiDAR side. We started with Velodyne. I think all of you know Velodyne brand that produce a large portfolio of LiDAR, especially this PAC series. And from this PAC series, we started to integrate the models like standard 16-channel PAC up to PAC Ultra with 32 channels. Here's some technical specs. The models differ by number of channels, by range, by weight. Have declared range accuracy plus minus 3 centimeter for distance meter, and this is how our system looks like. That all is integrated in one unit. So we integrate LiDAR, we integrate GNSS, IMU into single compact and quality-made device with easy-to-use interface. This year we have switched to another, or we started to integrate a new brand. It's a Hesai company with a similar form as a Velodyne, and the similar parameters like choice of 16 or 32 channels. There are similar choice for the ranges, which goes for one special model up to 300 meters. Similar weight, but what we see as a very big benefit of this model, of this brand, is the range accuracy, which is now declared for up to plus minus 1 centimeter, which is really very high range accuracy. And comparing to Velodyne, it's 3 times better, and it's really make the final point clouds less noisy, much clearer, with better visibility of the details. So this is something we are happy to find this manufacturer, this brand, and we are happy to integrate it, especially for the customers looking for cost-effective but high-quality solution. Even for more demanding customers, we integrate also LiDAR from Teledyne Optech. It's a company, you know for sure from Canada, called CL360. Beside the previous model, this is a single beam LiDAR, so it's like a profiler with only single beam, but rotating with very high speed. This speed can be up to 250 lines per second, providing really very dense point cloud with great range accuracy, which is stated on 5 millimeters, so the most accurate LiDAR we offer. And its range is, of course, much bigger than the previous models. Can be for HD model up to 490 meters. This is more heavier model. Okay, so but still capable to be mounted on heavy lifter drones like Air6 from Air8, like from Air6 robotics company, but also for the car, and yeah, it can be carried also in the backpack setup. So this is our portfolio of the LiDAR we integrate. So we have a big choice of LiDAR depending on the requirements on the customer and of course on the budget of the customers. What is important to know, what we integrate as a positioning system or inertial positioning system, we don't want to compromise on the quality. So as a long-term Novatel partner, Novatel dealer, we integrate OEM GNSS receivers with the highest quality produced by Novatel and tightly coupled with IMU also produced or proposed by Novatel company. So this is GNSS technology which is, let's say, used by Leica Geosystems in their surveying grade GNSS system, RTK rover. So it's really highest quality of GNSS positioning, and IMU is really high performance comparing to its weight and size. It's perfectly fit into our compact LiDARs, providing very high rate output up to 200 Hertz and providing very good heading accuracy, which outperforms similar IMUs of other manufacturers. Here you can see the workflow we use. It's maybe if you know the workflow of the traditional LiDARs like we produce, it's very similar. So and quite easy because we just log on the platform on the LiDAR side. We just logged all data into internal memory of the LiDAR. So there is no RTK, there is no any special communication, correction, transfer, or communication channels needed. You just simply switch on the device and it starts to log all positioning data and scan data into internal memory. And then those so-called raw data needs to be processed in the computer. We use for processing trajectory, we use Inertial Explorer software, which is a software provided by Novatel company, and it's standard PPK approach, so post-process kinematic approach, when you need also to add the data from the base station or a permanent of course reference station to process trajectory within very high 1-2 centimeter accuracy, of course, depending on the condition for the GNSS satellites visibility or tracking. Then with this trajectory having computed, processed, and having a scan file, we use LiDAR Creator software, which is our own developed PC software for merging those data. and then you can output georeference point clouds, which is a standard output of mobile LiDAR system. Then the third software coming after that is a software for so-called post-processing LiDAR data or point cloud data. And here we can do some recommendation to our customers, but we let the choice on them because there is plenty of point cloud processing software available, and the choice really depends on the application you have, what outputs you need, what quality, and so on, or even what budget you have. Just one slide about our LiDAR Creator software we developed here in our house, and as I said, this software merge process trajectory with the scan data, synchronize all data together, and allow the user to select which part of the trajectory has to be exported, provides quality graph reports so the user can see the trajectory and places depending on the condition which were available at the time of scanning. Along with the LiDAR, the user can mount different cameras, 360 camera or even GoPro camera, to take a video record along with the LiDAR scanning. And we have an integrated special player for this video within this software to see what was really scanned, and this provide more details about scanned objects. We can output georeference point cloud in several or really many coordinate system, depending on the country where the LiDAR is used. We have integrated many filtering options for removing outliers point, for removing the noise, filters based on intensity, or filters based on distance from the LiDAR. Within the same software, we can do RGB colorization. So if some video or images were taken during the laser scanning, we can use it for assigning real RGB colors to the point cloud, making the point cloud nicely visible, or some details are better visible. And latest add-on functionality into the software is that user can do a profiles and can do a quick check of the consistency between a data, like you can see on this picture of several passes, and on the overlapped area you can see how these passes fit together, and you can adjust it between, or you can add a control points. And then if it's really very challenging condition on the ground, like environment with the trees or high buildings, then you can use a control points to adjust the point cloud or the trajectory to fit better to these control points, and to get very high positioning accuracy even in the challenging condition. We can combine LiDAR with other sensors installed at the same time, let's say under the drone. It can be RGB cameras, either like mirrorless cameras or 360 cameras, and to use the outputs, images, or the panoramas or the videos for RGB, mainly RGB colorization. but also for can be used for common photogrammetry and scanning. And we can also combine LiDAR with special sensors like multispectral sensor used mainly in agriculture, or thermal sensors providing special output, special data, and to merge together or overlay to data from several sensors. Here's the example of very good combination of very powerful drone from Air6 Robotics company, Air8, capable to carry all products or all portfolio of LiDAR very easily for very, I'd say, long flight times. We cooperate with Air6 Robotics. I think it's 3 years already. We did several demos attempts. We have customers using LiDAR or Air8 especially, and yeah, this combination is very powerful and productive, allowing to fly pretty long time in the air to provide high efficiency of the 3D data collection. Now I would switch to applications, because the hardware and how it works, it's very nice, but I know that people are more interested about the outputs. What outputs can I get for my application? What the quality is? What is the details? What I can do with the outputs from the LiDAR. So I can say that this is a really world of the application. There's a lot and more comes. It depends really on your imagination, how to use LiDAR, because it's about 3D data capturing. And when I can compare it with the traditional, let's say, surveying method to measure points by points, to come to one location, at another point you have to move between them personally, and to store point by point, comparing to LiDAR mobile scanning, when you within minutes are able to capture 1 million points. So it's really big difference, and huge step in the productivity of the fieldwork. This fieldwork, it's then very much more shorter, and more of processing data is happening in the office, which is much more comfortable for the users. So just to show some ideas how to use LiDARs. The standard surveying grade application is a measuring of the, let's say, building landscape mapping. We call it here like virtual surveying, because instead of measuring the points in the field, the user can do the same in the office by picking the points from the point cloud. So he just needs to find the position of the points he can pick and store, and he will get the point with XYZ coordinates with survey grade accuracy, and he can store it. He can add some coding, some features, and store it the same way like he does traditional way in the field. So this is the idea of virtual surveying. Then of course point clouds as a standard outputs needs to be converted to the more traditional CAD formats, 2D or 3D. Modern approach is to use it for digital twins and beam application, which is really ideal outputs from the mobile LiDARs like this. real estate is a big option or opportunity to use LiDAR data to present property, to measure areas, distances, whatever you can measure on 3D data. Here you can see the output from our recent common scanning from UAV, once in RGB coloring, in second in so-called classified point cloud, when you can see the differences or different color assigned to buildings, to high vegetation, low vegetation ground. So this is the way how to differentiate object in the point cloud. Another very important area of use of mobile LiDAR is energy market, when the LiDARs are used for power line mapping, power line corridor mapping, when you can, let's say, fly with the drone or even with helicopter over hundreds of thousand meters of up to several kilometers of the power lines, and to capture this 3D data with very high accuracy and efficiency, and to use the outputs for several applications like infrastructure inspection, when you want to know what are your objects, what is on the ground, what is your inventory. Very special application and useful is vegetation encroachment detection, because this is very important for the safety of the power lines, of the wires, to find if there can be some conflict with the trees, growing trees around the power lines, and to finding if the distance is safe between the power lines and these growing trees, because the situation is changing from year to year. Trees are growing, and the distance between the power lines is smaller and smaller, and this can make a risk for the damage of the wires. If, let's say, if the tree could fall over the wires. Another big area of use is a forestry. Forestry, especially from the air, so from the UAV or helicopter, you can map large areas of the forest, and the goal is, let's say, to count the trees in the forest, individual segment. There are very clever software who can identify individual trees in the forest. Then you can count them. You can make analysis of these trees depending on the height or on the mass of the wood. You can calculate crown area very easily in a special software allowing this. So here you can see how looks a profile over the forest, when you can see distance or measure distance from the ground to the top of the trees. And also this picture shows you the effect of multiple return of the LiDARs, that the multiple return on LiDARs can detect the ground under the trees, and this is a big advantage of the LiDAR against technologies like photogrammetry, when photogrammetry is not able to penetrate so well through the canopy, through the vegetation, and this is the big advantage of the LiDAR to pass through the vegetation, to find the ground, and then this ground can be classified, and digital terrain model can be created. Another interesting area is agriculture. So we are moving more from this geo application to more, I would say, no geo application, when the people in agriculture can benefit also from the output from mobile LiDARs, because the capability of LiDAR to capture the 3D space and objects in 3D space allows, let's say again, create digital terrain models which can be helpful for minimizing the erosions, or you can plan irrigation based on analysis of the shape of the ground, but you can even measure the growth of the plants on the field when you do some continuous scanning in different time periods. You can compare and count the growth of the plants in the time. And of course, let's say if something damage the crops, also you can do a scanning and to measure the impact of this damage on your crops. Okay, and last slide with the application is a construction market, and here you can see some examples of what we do. Let's say this first one is a construction of the big museum in Budapest. It's a big construction site where we did a scanning for monitoring the construction progress to see how the progress was in certain time. Below you can see the project for scanning for the land where the company from Germany will build big storage halls. So first they need to know the terrain to see how to make a project, how to project his hall to the real terrain, and what is important for them to compute the volumes, because volumes mean a lot of money to take a soil and to carry it out. And from such a 3D data, they can easily count how many ground needs to be moved away and what they will pay for it. Okay, so this was just a few areas of using LiDARs like LiDAR is. So it's really a huge number. And so at the end, I would like to summarize the highlights and benefits of our system. So we offer a unique multi-platform solution, which for the customers is big saving on the investment, buying and using one device for different platforms for different applications. We offer a choice of the LiDAR modules from several manufacturers, and we can offer the solution fitting for specific needs of our customers. We use best positioning system from Novatel because we want to offer really high accuracy of the outputs, because we see it as really very important as a positioning quality. Our system are scalable and upgradable. It means that we still have a roadmap of the improvement of our system, and we can grant to our customers that we can upgrade even older version to new version, having new features or better performance of our systems when it will become available. With the accuracy grade, we can fulfill even requirements for surveying accuracy. compact size and weight, is really optimized for using on UAV platforms, because this is more sensitive for the especially for the weight. And we try to offer a system for affordable cost. So we want to be competitive on the market and to bring fast return on investment to our customer. So thank you very much for your attention. And now I give the word to Keegan.
Great, Eric, thank you very much for your presentation. I found that very, very insightful on my end. I'm sure everybody else did as well. At this point in time, yeah, I believe everybody else has got things to do. So if there are any questions, please feel free to email either Eric. You have Eric's email address there in front of you, info@LiDARetto. Alternatively, you can reach out to us at Air6 Systems and Airborne Robotics. I would like to thank everybody for your time and joining us today, and hopefully we'll be in contact with a few of you in the future. Alex, Eric, final words from you?
Well, same from me. I would like to thank everybody. Was great to have you so short before Christmas. I appreciate, it's always difficult in the week before the holidays. So a lot of people have left, which I can see here in London, have left already on holidays. But thank you for participating, and again, hope to see you soon at any of our other presentations, maybe also live events. We will be hosting live events in the first quarter and second quarter of next year. Of course, when it's outside and warmer, it's easier to do that than in the winter period. Thank you, and hope to see you soon.
Thank you also from my side for your great attention. And as Keegan said, you can email me or even call me with your questions. I'm here to answer everything you want to know about our LiDAR system. Thank you.
Fantastic, Eric. Thank you very much. Alex, thank you very much. And for all those attending, thank you again. Wish you all a very Merry Christmas. Stay safe out there, and we'll be in touch and see you soon. All the best.